Is it visible?
Yes, it is.
Perfect. So, good afternoon, all. And I'm just taking you to the next slides. But before that, just important is safety. We are all working from a respective location. This webinar is a virtual webinar. So it's very important to know your nearest safety exit. My friends who are listening this webinar from a remote location or from home, ensure that there is because you will be on headphone, so you keep someone informed about the emergency. Otherwise, you will not come to know if there is any sirens. Alpha Laval is basically committed towards COP27, and we have our climate targets, and we have a climate target of reducing our Scope 1, Scope 2 to 50% in 2023 itself. Scope 3 reduction also to 50% by 2030, and Scope 1, Scope 2 to 0 by 2030. So we would like to achieve our carbon neutral stage by 2030 and net zero by 2050. And these are been very well managed, and we are monitoring this. And towards that, we are focusing on sustainable sourcing. So we are working even towards the raw material, the steel which we are using for our equipment may not be from a virgin steel. We have already moved to renewable energy, and we are putting our all best efforts for optimizing the production and reusing heat and water wherever possible. At the same time, we are also promoting, and we are also educating our customers about how sustainably we can utilize our equipments. Our sustainable goals are SBTi approved. So these are been very well acknowledged that these are science-based targets. As far as Alpha Laval is concerned, Alpha Laval is engaged into three major technologies. First is heat transfer, wherein we are having a lot of thermal equipments. Based on the application, we recommend and suggest the best possible equipment. Separation, we are into solid liquid and liquid separation. And we also engaged into fluid handling, wherein hygienic fluid is being handled, and we have pumps and valves fittings in that. So, ladies and gentlemen, with that, I would like to take you through through few interesting topics today. First is to know what kind of utilities are there in any process plants, and then what are the savings opportunities. If you have a process plant where you can look at the possibility of savings, heat exchangers is something wherein lot of technology, lot of innovations are going on. So, what are the new features in heat exchanger, and how we can utilize the heat from exhaust gas? So to know first utilities, if you look at any process plant, you will have some heating media. So probably you will have steam generator or a hot water generator. Compressed air is being used in lot of processes and even to drive instruments and valves. Many processes needs hydraulic power unit. And then for refrigeration, sometimes you need ice storage or chiller or and there is a cooling tower water in lot of processes to ensure that there is no interrupted power supply. Many process plants will have either captive or cogeneration power plant or their own generation. Sometimes also there are plants which are near river may even utilize the water, filtered water for the process. So as far as utilities are concerned, a normal plant will have compressed air, steam, cooling tower, water, some of these water and electricity, natural gas, or even fuel. Heat recovery from waste water. Many plant will generate steam from the boiler. Steam goes to the process, and then sometime it is directly injected, or sometime the condensate which comes may be contaminated. If it's a contaminated condensate, it does not go back to the boiler, but it is being sent to the PTP plant. Many times the water is being cooled with cooling tower, because for effluent treatment, the many times there is a process requirement that this water should not be at a higher temperature. It should be at a room temperature for a better water treatment. So sometimes even a cooling tower water is being circulated to cool it down. What we propose is, before cooling it, take it separately, put it in the tank, put a filter, and then from filter, we can use the heat at least to preheat either boiler feed water or even the process water. In fact, many a time, if we reduce water temperature, the same water can be circulated. So we can achieve even water saving. We have done few projects like this, and one of a sample project where we have got a ROI, a very attractive ROI, and this is a typical textile plant where wood is being used for boiler feed water, for generating steam, and very attractive payback with the duty conditions of 7 meter cube per hour. While doing so, there are some challenges, and the challenges are, if it is fibrous fluid, then it is very difficult. If it is contaminated fluid, it is very difficult to use any heat exchanger. So typically, if you look at heat exchangers, you have very efficient heat exchanger, which is a plate heat exchanger, and a heat exchanger where you can use fibrous or a slurry kind of a liquid, which is a shell and tube. But then there are advantages and disadvantages of both. If you look at advantages of shell and tube, it's the fibrous liquid can go, and if you look at disadvantages of PHE, there the choking chances are high. However, there are some disadvantages of shell and tube, which I will cover in next slide. But we have replaced shell and tube with plate heat exchanger, and we have achieved a fabulous saving. Why? Because shell and tube cannot work at a 1 degree or 2 degrees approach. It has to work at 15 to 20 degrees approach. However, plate heat exchangers can work at a 1 degree approach as minimum, as high as 4 to 5 degrees, even considering if you have a wider channel gap. These are actual log data wherein you can see that effluent outlet temperature and water inlet temperature, there is 1 to 3 degrees, 1 to 5 degrees temperature approach. And this is quite possible if you go for a efficient heat exchanger like plate heat exchanger. Having said the shell and tube, the disadvantage, but to know disadvantage, you need to see how shell and tube operate. Shell and tube normally operate with multiple passes. So this is a typical drawing where there are two passes is been given. So in first pass, this is the shell side and this is a tube side. So if you look at shell side, this is co-current, and on other side, this is counter current. However, if you look at plate heat exchanger, it is your choice. You can have counter flow also. And if you go for a counter flow, you can achieve the approach as low as 1 degree. But in shell and tube, it is not possible. And our observation is, if you replace shell and tube with plate heat exchanger, again, provided a duty conditions, fluid allows, you easily get a saving, and the payback is less than a year. Next is flash steam and condensate subcooling. In flash steam and in typical process plant, the boiler generates steam. Steam goes in the process plant. Process plant generates water, condensate, and steam trap separates it. It comes to either flash vessel or it goes to straightaway boiler under the back pressure. This is very good system because you are utilizing heat, you are utilizing condensate, you are utilizing water. However, the problem is this complete system is under pressure. And many a time, if there is a back pressure, it has been observed and challenges, the equipment will not be, the condensate will not come out from the equipments easily because there is a very less differential pressure. What we propose is put this condensate in a flash vessel, take a flash steam out of flash vessel, use a heat exchanger, utilize this heat to preheat your process water and bring condensate at a atmospheric temperature, atmospheric pressure. If you feel, you can even subcool this by using another heat exchanger so that you get condensate at 60 to 80 degrees. And with 60 to 80 degrees, it is very easy to manage condensate, and then it can pump it back to boiler, wherein you can use this water for as a recovery of water. And whatever, finally what is important is saving the heat. Once you save this heat, probably you will have to generate less steam out of boiler, and the steam consumption, the fuel consumption probably remains same or little less because you are utilizing the heat. Important factor is it will be easy to manage system because you are depressurizing the complete return line. Um, this is a typical food industry plant where flash steam was vented, and we recovered flash steam. And we observed that while after recovering the flash steam, the payback period was just 2.7 months. And it's not the saving of close to 60 lakh rupees, but also we could save a carbon emission of 181 tons per year. Uh, Having said that, it's not that it is the normal plate heat exchanger. The normal plate heat exchangers will be tall plate with smaller port size. But when it comes to steam, you need to have a shorter plates with a bigger port size. Why? Because these are condensing duties. So same plate heat exchanger is not suitable for condensing application and for sensible heat transfer. Next opportunity uh, for better utilization is cooling tower, open cooling tower. Many process plants will have cooling tower, and these are typically open cooling towers. Yes, there are closed cooling towers now available, but the open cooling towers installations are very high even today. What happens in open cooling tower, the return water of 37 degrees approximately comes to cooling tower, and then the water evaporates. Once water evaporates, the concentration of calcium carbonate and total dissolved solids goes up. So when it goes up, what we normally do, we add chemicals. Even after adding chemical, we realize that the water TDS is very high. So we flush, add makeup water. This is the way we maintain calcium carbonate percentage, calcium carbonate content in cooling tower water. But even after that, we end up with having such kind of scales. And there are typical areas, coastal belts, where it is very difficult to get the water. The groundwater itself will have 800 plus TDS. And this kind of scale formation not only increases the maintenance cost, but even the pumping cost. Even after that, there are a lot of breakdowns, and many a time you have to take shutdown, and there is a production loss because there are equipments which are working inefficiently. Plus, if there is a scale formation, it will hamper your heat transfer efficiency as well. So what we propose, what we suggest to customer is put a heat exchanger in between, and heat exchanger which is more efficient, so that which can work at 1 degree approach. And if you have 1 degree approach, you can isolate, you can make a closed circuit for water which is going to the process, and high contaminated water can remain to close to the cooling tower. Now, by doing that, I know that my process is not going to hamper by higher TDS. So I can even increase the level of TDS. I can reduce flushing. I may even reduce chemical treatment, and I may reduce the makeup water. At the same time, I can ensure that there is a good uptime and efficiency, and there is less repair and replacement cost, and chemical dosing can also be reduced. Plus, there is sure short operational cost saving. How it is so relevant, for that we need to understand how calcium carbonate behaves. Okay, so this is a typical example where if you see, calcium carbonate doesn't work like sugar. When you increase temperature, the solubility of sugar increases, but in calcium carbonate, the solubility reduces. So, if you look at your geyser, water geyser, or uh, uh, you know, tea making machines, you will find that scale formation is very high on the coil. And why it is high? Because calcium carbonate sticks on the hot surface faster. And to explain you even much better, if you look at, if this is a condenser coil tube, and if there is a scale, and that scale, say for example, is just a 6 mm scale is there inside, the condensing temperature increases, increasing the compressor pressure. And compression ratio is a ratio, and when compressor pressure increases, automatically electricity consumption goes up. So just 0.6 mm thickness can increase the electricity consumption up to 20%. There are some sample cases where we have achieved the savings, wherein there are there were 30 equipments which used to have lot of challenges, and there the saving achieved is less than 2 years, with additional savings of better utilization and more efficient heat exchangers, better control on the plants. Uh, After cooling tower, we have compressors. Even in compressor, if you look at compressors, works on the electricity, and 90% of electricity which is consumed for generating hot air is basically goes into the oil. And how this is this is a compressor. The oil which goes inside will carry 80% of the heat. 10% of the heat will go into air, and 10% will be dissipated in the parts of compressor. So 90% of the heat is potential to recover. How it can be recovered? It can be recovered by this schematic. A typical case is humid air comes in the separator, it goes into the screw, and then after separation, air goes to air cooler and oil goes to oil cooler. Okay. What we can do is we can take a tapping after a control valve, and this oil can go to a heat exchanger, and from this heat exchanger you can generate a water at a high temperature. I mean, you can generate water at 40, 35 60 65 degrees temperature. This water can be used for boiler feed water, it can be used in canteen, it can be used in any process wherever it is possible. And this is basically a bypass to your existing heat exchangers. So if you have even a compressor, uh, existing compressor, there you can very well recover the heat. Uh, to explain you in more detail, this can be a heat exchanger with oil and water line. So this is typically oil line, and if temperature of oil is more than 55 degrees, then only it will go to the heat exchanger. Otherwise, it will come to the return line, and water will come from other line, and you can generate hot water, and this will reduce the fuel consumption in boiler. This is the typical 100 kilowatt air compressor, which is very commonly available in any industry, any process plant, and there the actual payback has come to 5 to 6 months, and this has been followed by one of a renowned MNC, and they have decided that they have 70 plus plants in India, and they are replacing all their compressors with this compressed air heat recovery, or hot water generation from a compressed air oil. Then many plants also has got ammonia used as a refrigerant, and this ammonia refrigeration has got an opportunity wherein due to a property of refrigerant, it goes in a superheated zone, So after evaporation, when it goes to the superheated zone, this superheated in this superheated zone, you can again generate hot water before and current practice is it is been lost in a condenser. So instead of losing that heat, we can utilize this heat to generate hot water again. And ammonia refrigeration typically used in a chemical plant in food industry, wherein this hot water can be very well utilized for CIP, for boiler feed water. This is a typical calculations of one of a case where payback has come just in 6 months, and for just 170 TR condenser. Uh, this Yeah. So, as a summary, we have seen the energy saving applications wherein we can have electricity saving, we can have fuel saving, and we can have the savings coming out of efficiency and uptime. Uh, Having said that, the plate heat exchangers which are currently available have also gone through a lot of innovation, and not necessary that all the PHE ports should be circular in nature. You can have ports which are omega shape or oval shape, because when fluid flows from pipe, if you see, the center of gravity moves and it makes a oval shape. So by just making the ports in oval shape, uh, you can reduce a pressure drop by approximately 20%. And 20% pressure drop is like 20% saving in electricity. Similarly, the pattern, the distribution pattern, wherein if you see, this is the smaller, shortest distance, and this is a longer distance. So fluid which comes in the plate area takes more time, or pressure drop on for reaching at a farther location is high, so than compared to the shorter distance. Because of this, we have observed that any plate heat exchanger will have more choking and scale formation problem on a farther side of a plate, of a port. So there is a heat exchangers where you can have this distribution area equally, pressure drop is equally managed. At the same time, the fluid, this heat transfer area on one side of a plate can be different to the other side of the plate, because it is not necessary that on both side of the plate heat exchanger you will have same fluid with the same CP factor and with the same temperature duties. Many times it is observed that fluid, the flow is different on both the sides. So you can even go for a similar areas, a similar plate pattern, wherein you can have heat transfer area on one side is different than other side. Uh, Also, if you do not size heat exchanger properly, you come across such kind of scale formation. If the velocity turbulence is not properly maintained, there are such kind of scale formations. So it is very important that PHE or any heat exchanger is sized. It is not necessary that oversized heat exchanger, or if your heat exchanger has got more area, is better. More is better is not the formula. Efficient should be the selection factor. With this, I would like to present some tips to maintain the heat exchanger in a better way. First is the operating conditions should comply to the design specification. What you have designed, what you have asked heat exchanger for, use that heat exchanger for that application. At the time of startup, it is very important that valve should be opened very slowly. Otherwise, there will be water hammer and pressure surge problem damaging the heat exchanger. At the upstream of a heat exchanger, strainers, filters are more required, because if you use those, it will reduce the cleaning frequency. So it's better to use strainers and filters. Check the changes in parameter. It is observed that many a time we design heat exchangers and there is a capacity expansion. We use same heat exchanger, but then the capacity has increased. So whether we are using that heat exchanger with the same conditions or not, need to look at. There are tightening bolts on a heat exchanger, on plate heat exchanger. Ensure that it is well lubricated and clean. Uh, there is no harm to conduct performance audit on the heat exchangers which are already installed, because it may be possible that heat exchangers which you have taken, which you have purchased at the time of project execution, probably running with a temperature approach of 5 degrees or 10 degrees. But now you can go for the same heat exchanger can be converted to even 1 or 2 degrees approach. uh, CIP is a better practice, because if for doing CIP, you need not to open a heat exchanger. So if you do CIP regularly and maintain it in the logbook, it will help for it helps for maintaining the equipment. You need not to open more frequently. Standby unit, use it whenever required. So it's better to use it for alternate period, and protect heat exchangers from water splash, rain or UV. And most important, it is very mandatory. I mean, it's mandatory to have a earthing done on a plate heat exchanger, and always use genuine parts. Uh, with that, I would like to present uh, the way many a time there is a waste heat coming out of process, which is the temperature is high. So there are like steel plants and many process plants, glass plants will generate wherever there is a oven or furnaces. The heat, even exhaust gas, comes at a very high temperature. When it is at very high temperature, in fact, it can be utilized even for, even there are heat exchangers made to handle such high temperature exhaust gas as well. And and it's not necessary that the amount of waste exhaust gas should be high. There are heat exchangers made with capacity of just even 5 kilowatt to even 400 kilowatt. So you need not to go for a very high heat exchangers, and these heat exchangers are very compact, and it can be designed to handle the thermic fluid and coolants as well. So that's it from my side, Bhavana ji. If there are any questions, and this is my contact. So in case you're looking for contacting me, please, you can reach me anytime.
Yeah. Um, Thank you, Amit. That was a great presentation, and new technologies coming up for energy efficiency, and especially for heat exchangers. So we all got an overview of that. And now I open the floor for questions. Please type your questions, or you can raise the hand so I can allow you to talk. So, questions, please. Yeah. Any questions? Yeah, there's some.
Yeah.
Mr. Balaji Sundaram has a question, and I am allowing him to talk. Yes, Mr. Balaji.
Yeah, good afternoon all.
Good afternoon.
Balaji from Thermex Power Division. Okay, I'm having one doubt in the presentation what Amit has taken. And that cooling tower, we are supplying many cooling towers in the power plants. So one slide he has shown that cooling tower we can recover some heat by putting a plate heat exchanger before that. I could not. I'm not getting exactly what I'm just telling that. In what way? Okay, we can reduce the blowdown as well as the makeup water, but how in precise? I would like to know.
Thank you, Mr. Balaji, for your question. And it is not heat recovery. I have not mentioned heat recovery in that by putting plate heat exchanger, surely you will not do any heat recovery. What you can do by putting a heat exchanger is you can convert your open loop cooling tower to closed loop cooling tower. Okay, and in that you are isolating the secondary circuit, the process water, the cooling tower water, which is going to process, will be isolated from a high contaminated calcium carbonate. Okay, so by doing that, you basically save in a efficiency and by uptime. So in maintenance cost, you save.
Okay, okay. Yeah, that means converting open loop to closed loop cooling tower. We can reduce the fouling and okay, we can improve the water quality.
Absolutely, absolutely.
Okay, but power consumption will increase or how? Because of
Yes, if you look at the savings calculation which I have shown, there is an additional pump, and that additional pump operating cost is being considered. Definitely, there is one additional pump which will be running, and that will have a head equivalent to a height of a cooling tower, which is not major, but the kind of savings you will get. I mean, everyone. If you ask any maintenance manager, he will tell you what kind of pain it is
okay,
to maintain cooling tower calcium carbonate, and probably that is the main reason Thermax also has got closed loop cooling tower.
okay, okay. Thank you.
Yeah, now Mr. I think, yeah, Ranjit Raj R. So you may put your question, please.
Good evening, sir. Sir, actually, I have a doubt. I am from IIT Ropar. I am doing energy auditing activity here. So one of our client actually asked a query regarding the heat recovery from the clinker production area actually. So the problem with them is actually they are spraying water over the clinker for cooling, and they are trying to extract heat from that process actually. They are recovering heat from the steam. They are trying to. So there is a problem with them actually. The steam is mixed with some amount of clinker also. So while designing a heat exchanger, there is a problem because this clinker is also mixed with this steam. So there is a chance for reduction in the effectiveness of the heat exchanger by gradually. So can you suggest any particular heat exchanger for this particular application? Any special type design or any?
Actually, Ranjitji, we will have to see the process. We'll have to see what kind of contamination is there in that steam. Uh, and but it's unfortunately any kind of contamination is not possible to clear with the heat exchanger. But then there are many heat exchangers available wherein even a slurry can be passed through those heat exchangers. So certainly, if you just can drop me a mail or message me or share your contact details, I will connect with you to study the actual site conditions, and we will recommend you a best heat exchanger possible for that application.
Okay, sir. Thank you. Thank you.
Okay. So, Amit, can you just share your screen for contact numbers so that is visible?
Should I drop you my contact details in the chat box?
Yes, that will be better.
Is better.
Yeah. Yeah. And now the next question is from Nehal Gupta asking what is the minimum temperature gradient for PHE?
Minimum temperature gradient for PHE.
PHE, yeah.
Mr. Gupta, you are talking about temperature approach. Then it is, you can go even to 0.5, but the approach is more closure then your heat exchanger becomes a little bulky. But a normal recommendation is 1 degrees for plate heat exchangers.
Okay, I hope that answers your question, Nehal. And now next question is from Mr. Anish Rajendran. He is asking, can you give some knowledge on a diabetic cooling tower? How can it be efficient compared to induced draft conventional CT?
Sorry, Anish ji, but I am not technically sound on a cooling tower technology. So I won't be able to answer this question. I'm sorry for that. Because I am not cooling tower expert.
Yeah, sure. Definitely, it can be later on communicated with some of your colleagues.
We can come back. We can come back to you.
Yeah, you may just note down his coordinates so that you can communicate.
Yes, or I can connect you to a cooling tower manufacturer.
And now the next question is from Atul Vyavare. Nice presentation on heat exchanger. It's not a question, it's an appreciation for your today's presentation. So that was a nice presentation on heat exchanger energy conservation opportunities. Thanks for clarifying the ideas.
Sure, Tulsi.
Yeah. Any further questions on this? Yeah, regarding PPT, all our presentations recordings are will be available on our AEE LinkedIn page, and already in Q&A section you can see the link for that page. So by Monday, this presentation will be available on the page. Okay. So no need of sharing PPT separately, but the complete presentation will be available there as a recording. I hope that answers your question. And yeah, any more questions? Yeah, contact details. Amit, you will have to give contact details in Q&A section, not in chat section.
I'm so sorry. I'm so sorry.
That is internal. Chat is for co-organizers only. Yeah. So here it is, Amit Goliwar, amit.goliwar@alphalevel.com. And mobile number is also given, 8799 68300. Yeah. So that was wonderful, Amit. I mean, we have learned a lot about heat exchangers and plate heat exchangers and new technologies that are coming up. And we hope to continue this discussion further also, individually or in say some other sessions also. Yeah. And let me. Yeah.
And thank you, Bhavna, for this opportunity. And this is also, I mean, I would also like to request all the participants, attendees, that this webinar happens twice in a month by AEE. So do join even next month webinars also. We will have some interesting topic coming up.
Thank you so much, Amit, for this question. And we look forward to further interactions with you. And request all attendees to keep attending our programs so that, and also give us feedback so that we can organize it in a better way in the coming year. And please let us know if you want to go for memberships. You can contact me on WhatsApp also, and I'm giving my number to communicate. That is 98230 so that we can have more members and more interactions. Thank you so much.
Thank you so much.
Thanks everyone for attending. Bye. Goodbye.